my name is Calvin Bacon and I am the product specialist at InstaLOD. Today we're going to have a look at how we can optimize our 3D scenes and basically take them to the next level in regards to optimization. And with optimization, I don't only mean the classic Polygon optimization, but I do want to take it one step further. So we're going to look at optimizing materials, textures, and the overall file size, and so on. So with that said, let's start looking at today's contents. So I've broken this entire presentation down into 4 different chapters and 4 different problems that need solving, or in this case, that need optimizing. So the first optimization that we need to, or that we are going to have a look at today, is the polygon optimization. Then we're going to have a look at some texture baking to optimize the amount of textures and also optimize the draw call count. Then we're going to look at generating LODs. So that means if an object is further away, we don't need all of the tiny details, so we can optimize that model for that specific level of detail. And then finally, the actual draw call reduction, which is to optimize the hardware performance, or the overall performance of the game, or the application that you're working with. So let's start off with number 1, the polygon optimization. So the way to optimize here is actually pretty straightforward, and it's just a matter of removing edges and polygons so that you have less of them. Now, whilst it sounds pretty straightforward, actually doing it it just takes a lot of time, right? You've got to go in, you've got to figure out which edges can be removed, and then do it manually, step by step by step. It takes a long time. In this process, you have to make sure that the important details are maintained. The silhouettes, the boundaries, everything is maintained so that the model still looks good, but with a lower amount of polygons. The shading needs to be maintained and a lot more. Now, if this is done manually, it can take hours, if not days, depending on the complexity of the scene. If you're using algorithms to optimize, the issue you typically get there is that they're not very intelligent. So they just optimize in an arbitrary way and just remove edges almost on random. And even those that have algorithms that, look at the mesh are not really that great and end up giving you broken geometry, texture stretching, and a lot more. So when we do this whole polygon optimization, we have to make sure that we keep the details, but we also want to make sure that we don't go down too low to the point where the model just looks really chunky, the shading breaks, and those issues start appearing. So that is the first issue that we're going to have a look at in a few minutes. Then after that, we're going to look at some texture baking, so optimizing the amount of textures. So that means combining and merging them, creating texture atlases, which inevitably also reduces the texture pool, which is really nice. And also, because we have less textures, also reduces the overall file size, which is a nice side effect. Now, when looking at textures, there's one thing I always like to shine a light on, which is normal maps. Normal maps are typically baked using 16-bit textures, and that is typically a requirement for them to look good, because we need that additional information in those textures to generate good shading. If we were to use 8-bit normal maps, we could get texture banding, or that typically does occur then, and that looks pretty ugly. It's quite visible. So that is why we typically stay away from 8-bit normal maps. Now, with that said, InstaLOD is actually capable of generating 8-bit dithered textures, and these are very powerful. And what InstaLOD does here is generate a 60-bit texture and then sample that texture down. Well, it dithers it down into an 8-bit map. So that means we get around 90% of the visual fidelity and quality of a 16-bit normal map, but with the small file size of an 8-bit texture. And that is the beauty. So whenever I'm working for AR applications, web, anything that needs a small file size so that it loads quickly and is very responsive, that's where I love using these 8-bit dithered normal maps. Now, when baking and trying to do it manually, unfortunately it's not just a simple step of importing your model, click bake, and then wait, and you're done. That is what we would love to have as artists, but in reality, we then, after the bake, realize that maybe the UVs aren't great, maybe we made an incorrect UV split, maybe there's stretching going on, artifacts of any kind might occur. So then we have to go back, try to fix those issues in UV space, maybe even fix them on the model themselves, and then try to bake again, rinse and repeat, right? Until you finally have good looking results. So also that is a lot of manual work typically. Now, when looking at baking, we need a baker that is stable, creates good quality results, and also can handle big files. And I don't only mean big files in regard to the polygon count, but also big textures, because when we're working with let's say scan files, photogrammetry, you can oftentimes end up with massive files, hundreds of millions of polygons, but then you also end up with like 20, 16K textures as an input, because maybe you've scanned an entire city or something like that. So then in that case, you need a baker that is capable of taking those 16K textures, 20 of them at once, and then trying to bake those down into maybe, let's say, a 4K texture. And the baker has to do that without crashing, right? So that is a big issue, and you're probably not going to be able to find a baker that does that, at least not, with a good stability. So those are the issues that need to be solved when optimizing textures, right? Creating atlases, having a stable baker that generates good quality results without any artifacts. Easy to use, basically. All right, then the optimization number 3 is generating LODs. Now, this is typically done once you've created your LOD 0, right? Your high poly or medium poly mesh with UVs, textures, everything looks good. But then when you start moving away from that model, you want to have these different levels of details so that the overall performance of the scene is optimized even when further away, because you don't need all of those tiny details when you're far away. Now, generating these LODs manually is a massive ordeal, right? It takes a long time to do that, especially if you need to generate 5 or 10 different LODs. So yeah, again, using algorithms can speed things up, but they're not typically clever enough to figure out where to remove edges, and the silhouette starts to break quickly. Smaller details get removed immediately. That might be important for the visual noise, and so on. So we need a really intelligent optimizer to be able to generate usable LODs. And I'm going to show you how easy that is to do with InstaLOD later on. All of these different importances, these feature importances, details, shading, making sure that we don't get any texture stretching, the boundaries, silhouettes are all taken into consideration, and so on. And that allows InstaLOD to generate these fantastic different LODs with a single click of a button from the user's perspective. So that is number 3. And then finally, number 4, the optimization of draw calls. Now, this is a very important step, especially in larger scenes. If we've got a city with thousands of different objects, we need to make sure that the draw call count is reduced to the absolute minimum so that the performance is good. Now, there are different ways of reducing the number of draw calls, and InstaLOD has a beautiful feature called Material Merge, which kind of encompasses all of the issues at once, because draw calls are typically made up from different materials and different objects. So what material merging does is it merges all of the different materials together into a single material. All of the input textures also get baked together into texture atlases, which also optimizes the amount of textures and the texture pool. So that also kind of draws back into number 2 here. But then after we've done the material merge, we can also combine objects together and end up with one object with one material and ending up in one single draw call. So yeah. That is, those are the different steps that we're going to have a look at today. So let's start off with number 1, the polygon optimization. So first of all, let's dive into InstaLOD Studio XL. I'm just going to change the position of the camera so you guys can see the settings. There we go. Okay, so this is our standalone application, InstaLOD Studio XL. We do have a few plugins for 3ds Max, Maya, Unreal Engine, Unity, Blender. We've got a command line application for batch processing, and so on. Today we are going to be using the standalone and everything that I'm showing you here inside of the standalone can also be done within those plugins. There are a few limitations, but they're nothing that we would have to worry about today. So with that said, let me grab my first model. And then we're going to have a look at how to optimize models that are definitely not optimal to work with. So what I'm importing here is a model that is very, very densely modeled. We're talking about 1.3 million polygons, I believe. And just optimizing it down to, let's say, 50% is just not going to cut it because there's too much going on. Even if we were to go down to like 10%, as an artist, don't know if that is going to be enough or if it's going to be too much. So what we can do instead is use a really powerful setting that InstaLOD has within the optimizer called the maximum deviation. Now let's first have a look at what we've got here. So we can see we've got a total of 1.4 million polygons. If we turn on the wireframe, let me quickly change the color. There we go. If we look at the wireframe, you can see it's just one massive solid block of color, right? There's just so many edges going on here. And something that is a big issue is this. So we've got these flat surfaces. These are just flat planes. And they're subdivided to an incredible degree, obviously way too much. What we want is basically 2 triangles per face here, right? And then we've got all of these other flat surfaces on the back. And again, what we want is the flat surfaces to just be made up of a few triangles and then some more triangles along the curvature so that those bevels and details are maintained. But everything else can just be removed because it's just unnecessary. So again, optimizing to a specific percentage isn't going to work. It's just not going to be enough. So what we're going to do instead is use the maximum deviation, because what this will allow me to do, or what this will allow InstaLOD to do, is optimize as far down as possible, but retain the quality that we need. So what I'm going to do first is just a quick, simple 50% optimization, just so you can see what the issues are, just so we can really visualize it. And then after this 50% optimization, I will be optimizing again using maximum deviation. With the deviation again, it doesn't matter how dense the input model is. If it's already very low poly, then potentially optimizing to a small threshold, let's say a deviation of 0.01, potentially might not remove any polygons, because removing any of the vertices would exceed the threshold of deviation that we would be allowing. Whereas if we then have a really, really high poly dense mesh like we have here, it could remove potentially, let's just say, like 90%, hypothetically. So that is the beauty of the deviation. We are always going to end up with the same quality no matter what we push through InstaLOD when using this deviation. Whereas if we use a percentage, you can see here, not even the flat surfaces on the front have been properly optimized. There we go. Right, a lot of these edges are still retained because we just didn't give InstaLOD enough. We just didn't give InstaLOD the ability to remove enough polygons to the point where it makes sense. Because we can see on the rear, again, there's actually not been any polygons removed on these flat surfaces because we've only allowed InstaLOD to remove 50%. So that is the issue that we have in this case with the percentage. Now, if we have a usable LOD 0, then using these percentages is perfect. But we're going to look at that later on when we start looking at the different LOD and generating LODs. For now, I just want to make sure that I end up with a good quality mesh at a reasonable amount of polygons. And that is why what we're going to do here is set the percentage to 0 and only use the maximum deviation. In my case, we are... let's set this to 0.01, and I'll also set a second optimization to 0.05. Let's add a third one as well, 0.25, just so you can see how InstaLOD changes the mesh depending on how much we allow InstaLOD to remove. So for 0.01, the first entry, we are going to make sure that that deviation is set correctly. The second entry will set to 0.05, and the third entry will set the percentage to 0 again, and then the deviation to 0.25. So this is quite a big deviation. Let's just add one more, 0.5, just to show you what InstaLOD does at these big optimization levels, the big deviations of 0.5. If you go above 1, you're probably going to want to use it for a very distant object. Okay, so with these deviations set up, let's just click start. And now InstaLOD is asking us, because we have already processed the scene, right? So it's telling us the scene has already been processed. Do you want to process the original unmodified scene, the 1.4 million polygons, or do you want to generate these different optimizations from the mesh that we have in the viewport right now? Now, I don't want to do that. I want to use the original scene. So we're going to press this unmodified button. And now we're going to take those 1.4 million polygons and generate these different output meshes from there. So while InstaLOD is working, I'll quickly open up my task manager. Let's just tell that to wait. And here we can see that InstaLOD utilizes every single core available to the absolute maximum extent. And this is really powerful. So the bigger the CPU is, the more cores you have available, the faster this whole process will be. Now we can also see that, well, first of all, I've got an Intel i7 6700K. I have overclocked it to 4.6 gigahertz. And I've got 16 gigabytes of RAM. However, this is single channel. I did have 2 channels, but then one of my sticks broke, so now I'm running single channel, which isn't ideal. So you can see here, this is a decent computer. It's reasonable, but it's nothing high end. It's actually pretty outdated, to be completely honest. I built this around 6 years ago and have not upgraded it since. It's probably time for an upgrade, but there we go. This is what we're dealing with. So working again with 1.4 million polygons and optimizing it 4 times at the same time. So very, very impressive, considering that we're already more than halfway through. We'll give that a few more seconds, and then we can appreciate the different results. All right, and there we go. So we are now done. And here we can see that even for the 0.01 deviation, the smallest amount, we have generated a massive reduction. We're down to just 114,000 polygons. And here you can see what I was talking about. These flat surfaces, we don't need there to be 100,000 polygons per square, right? And now we have a very, very small amount of polygons. We could potentially even optimize these down to another 50% because all we really need are 2 triangles. Then all of the other areas, right, are very flat. And then where we have the details, we have the bevels, the curvature. InstaLOD allowed, InstaLOD maintained the edges to model these details. So with the 0.1 deviation, we can not really see any change, to be honest. Even if we get right up close, it's looking really nice. Now, if we start looking at the larger deviations, we should see how InstaLOD still maintains the silhouettes and everything perfectly, but simply retains less edges along the curvature and starts making things look a little bit more chunky. So to look at that, we simply have to toggle through these different tabs on top of the viewport. So we can see, there we go, 0.05, 0.25, and 0.5. Now 0.5 is very drastic, and we can see we're down to just 6,500 polygons, which is an incredible optimization. If we look at 0.05 versus 0.01, also here, fantastic optimization. And if we go larger, you can see things still look really good considering what we're dealing with here. But the overall curvatures just end up being a bit more, chunky, if that's the right word. But again, the beauty here is that I don't need to worry about figuring out what percentage needs to be used, what target polygon count needs to be used, because oftentimes I don't know. Just like in this case, with over 1 million polygons, almost 1.5 million, I don't know if I need 10,000 or if I need 20,000. I can just give InstaLOD the the information regarding what quality I want, and then I know for a fact that that quality is what I'm going to get as an output. This is especially useful in a batch process when we've got high poly meshes, when we've got medium poly meshes, and we're throwing everything in our asset library through this profile. We know that every assay is going to end up looking, everything's going to end up with the quality that we want it to have. So that is the polygon optimization made incredibly easy for us users when using tools like InstaLOD Studio XL. Again, everything I'm showing today can also be done with our plugins. So yeah. With that said, let's quickly dive into the slides again. All right, so polygon optimization was the first thing we want to optimize, right? The amount of polygons, we want to make sure that the quality is maintained, but we don't want to remove too many polygons to the point where the shading starts breaking and details start breaking. And we were able to generate that with this deviation by specifying the quality that we need. So the deviation of 0.5, if we're right up close, this would definitely be too low poly. But for a distant LOD, this would be perfect, right? If we get right back, we don't need all of those bulbs in the scene anyway. Potentially, we could even remove these really small bulbs in this light for this specific LOD. Now, we're going to look at LODing in more detail later on, but just so you know that even that is very easy to do here. Okay, so that was number one. Let's move on to step number two, the optimizing of textures, and in this case, baking them and merging them. So what we're going to work with is a character. Let me quickly see where I've got him. Here we go. And this character is made up of, I believe, 6 different meshes. He does have UVs, he does have textures, and he's got 130,000 polygons. So what we're going to do here is generate a new profile because I don't want to optimize him. Let's first have a look at what we have. So what we have here is, as mentioned, 6 different meshes. His cloth is separate. His eyes and mouth are also separate. And then his body is also a separate mesh. Now if I select the body and if I open up the UV viewer, we can see here the body has a single UV layout and texture. He also has a UV layout for the eyes and the mouth, including a texture and material, and then another separate material and texture and UV layout for the cloth. So that is the setup that we have here as an input. Now what we're going to do is, in our case, we're going to use the remesh. There are different ways of combining the textures. For example, material merging, which is what I mentioned earlier. But in my case, I'm going to use the remesher, which automatically utilizes the baker. The remesher is going to do a full reconstruction of the scene. It's going to generate new UVs, and it's going to bake the textures together into a new texture. And this is really useful because at this point, we've got 3 input materials. And we've got, I think, 4 different textures because, or actually even more. So we've got one material has an input norm map and a color. The other one only has a color, and the third one also has a norm map and a color. So that means we have 5 different textures across 3 materials, 6 objects. So those 5 different textures are now going to be combined into a single texture atlas. To do that, we're just going to go into the texture output, and here we can decide how the textures should be baked. So here we can decide what texture size they should have. We can go to 2K, we can go to 4K, we could even go up to 32K. And this is where we get back to the point which I was mentioning earlier, which is the option that we have here to bake huge textures. So remember earlier I mentioned I had the example of scan files, right, with 20 different 16K textures, you need a baker that is capable of dealing with those huge amounts of data in a stable manner. And this is it, right? The fact that we can bake 32K textures as an output in a stable manner, just, is really nice to see. It just conveys a lot of confidence. And because we can bake these huge textures, right, it works. So even when we're not baking 32K textures, even when we're baking it down onto a 4K map and we have these massive textures as an input, we can deal with them. InstaLOD can take them in, load them, and bake them together without crashing and generate good results, which is what this is all about, right? So yeah, that's just really nice to see that we as artists don't have to worry about any of this. We can just give InstaLOD the data we have, click a button, and not have to worry about it. It just works. So in my case, we are going to bake everything down onto a single 2K texture. We're going to bake the normal map and the color texture. So with that done, we're going to take the entire scene. We're going to click start and let it process. So from 130,000 polygons, generating a new reconstructed mesh, new UVs, and baking all of those different textures together. So from 5 2K textures, I believe we had as an input, we're now reducing that down to 2 2K textures, 1 normal and 1 color texture. Now at the same time, we're doing an incredibly impressive reconstruction, which isn't what this point is about right now. So I do want to concentrate on the texture. But the fact that we're going from 130,000 polygons down to just a handful is incredibly impressive here as well. So if you're interested in finding out more about InstaLOD's remesher, I do highly recommend checking out our knowledge base or YouTube channel, because today we're not going to look at these settings in too much detail. So here we've got the result of 14,000 polygons, so an almost 90% reduction down to just 10%. We've got a single watertight mesh here, modeled over these different parts, and in this case, one single UV layout with one single color texture, 2K, and a normal map. There we go. And you can see a absolutely beautiful bake. Now, the incredible thing here, which I haven't talked about, is that we've actually baked 3 textures, even though we've only got 2 textures selected here. The first texture is pretty obvious, that's the color. But then we've also got the normal map for the silhouette. I'm just noticing right now, sorry. I'm just noticing that I've still got the camera on top of the settings here. Let me just move that over. Okay. Okay, so just in case you haven't seen the bake settings, we've got those up here, the texture size, and that's, I believe, the only thing that you couldn't see that I was talking about. Anyway, so yeah, the 3 textures we've baked is the color texture, then the normal map for the silhouette, which is the object space normal map here, for the geometry, the silhouette, and so on. And then the third texture, which we've baked here, is actually coming from the input character. The input model had its own tangent space normal map. And that's how we ended up with 5 textures altogether as an input. So what InstaLOD did here is it generated the object space normal map for the silhouette and the geometry, then took the input normal map, the tangent space normal map, and then combined both of those textures together, and then had to recalculate those textures, those normal maps, so that it would fit and work on this model. And that is an absolutely incredible feature. As far as I know, no other baker is actually able to do that. And just to put some perspective into this, if we were to take the input tangent space normal map and just project it onto this new mesh, it would not work. It would never look good because tangent space normal maps are really finicky. If we just remove or change a single polygon on that model, the normal map is completely broken. Sorry. So projecting the original tangent space null map onto this model would never work, because here we have completely different polygons pointing in completely different directions. Therefore, InstaLOD has to do this entire recalculation of the null maps to get perfect shading, this really smooth shading across these muscles. Even though we have completely different geometry with completely different surface normals. And that's how we can get these incredibly beautiful shading results. So that pretty much sums up the second optimization step, which is texture baking. We are able to take multiple textures, combine them, create texture atlases. We're able to take normal maps, recalculate them. And we're also able to reduce the file size of textures by baking, for example, 8-bit dithered textures. Regarding the 8-bit dithered textures, you can set those up here. On the top right hand side in the texture output, we've got these different export formats, right? So if we hover over the object space normal map with the mouse, InstaLOD tells us that this is baked as a 16-bit RGB texture. And that tells me that, okay, these are the settings I now need to change if I want to change the way the normal maps are baked. In my case, I would then change it to the 8-bit dithered texture. You could go to 8-bit. But again, I do highly recommend using 8-bit dithered because of their superior quality. So then let's move on to the optimization 3, which is generating LODs. So again, generating LODs manually is a very tedious and time-consuming process. You typically start with an LOD 0, so that is your good, game-ready model, basically. But then you want to generate those different LODs for when you do start moving away from it. When you're further away, you don't need all those tiny details. So that is where you need to generate LODs. LODs are also used for different platforms. So if you're working on a game and you need to distribute the game on the PC, and then maybe 3 different consoles, and then mobile as well, you'll end up with maybe 15 different LODs. And then depending on if you're working on mobile, console, or PC, you'll then maybe use the first 5 or maybe the last 5 different LODs of those 15, 20. All right. So yeah, again, doing that manually takes ages. So let's go ahead and automate this process again using InstaLOD. So the benefits with InstaLOD are that we just get some incredibly high detail results. Let me just go back in the timeline here. So we are going to use this character again, but now we're going to use the optimizer and generate LODs. So in this case, we have our 130,000 polygons. We've got the UVs, we've got the textures. So this is a really good base to work from as an LOD 0. So if this is our game ready model and we now want to generate the LODs, what I want to do is go into the mesh operations and generate those different LOD entries. So for every entry here, I'm going to generate a single output mesh. And here I'm going to have my first entry, which is going to be LOD 0. I'm going to add another entry, which is going to be LOD 1, another one, LOD 2, and finally, we're going to add LOD 3. We could go on and on and on with whatever settings you want. Now, for every entry, we can change the feature and all of the settings, which is really powerful. So this gives me a huge amount of flexibility and control. For example, if I wanted to, I could have LOD3 be a billboard imposter. We could remesh LOD2 to maybe 5,000 polygons, and then we could simply optimize LOD1 to 50%, right? We've got all of that control if we need it. But for now, we're going to keep things really simple and only use the polygon optimizer and simply change the percentage. I'm going to set the percentage here to 12.5 for LOD3. Then we're going to set the percentage on LOD2 to 25%. And then LOD1 we're going to set to 50%. LOD0 we're going to use the optimizer and set this to 100%. So we're actually not going to optimize. We're going to keep the input model. Setting it to 100% is just going to pass it through without doing anything. So with these different LODs set up, we're good to go. If we wanted to, we could change a few of these feature importances. So if I were working with some scan data, from my experience, oftentimes even removing just a single vertex somewhere could automatically create some really bad texture stretching on the model, because with scan files, the UVs are very often just really bad. So that is where maybe you would need to increase the texture importance, or worst case, potentially even lock the splits so that all the vertices on a UV shell boundary are locked and those vertices don't get removed. That is only really the case when you've got really bad scan data. Most of the time, increasing the texture importance is more than enough. Maybe you're working with some automotive models and you need to make sure that the shading looks fantastic. Again, typically InstaLOD does generate some incredible results, even with 90% reductions. But if you do end up with maybe broken normal somewhere that you're not happy with, no one's ever going to be happy with a broken normal. But if you're not getting the results that you're looking for, then you can start increasing the shading importance. Now, with that said, I highly recommend only changing one of these feature importances at a time. I have seen users increase all of these to highest. I highly recommend not doing that because then you're just simply limiting InstaLOD's algorithms and it doesn't have any more control anymore. So by default, I would recommend keeping everything on the default settings unless you've got some weird stuff going on. So with that said, we've got our different LODs set up. We're going to optimize 100%, 50%, 25%, and then 12.5%. We're going to click Start, and with a single click of a button, InstaLOD automatically is going to be generating all of these different LODs. Now, for this model, using percentages works like a charm. If we've got a really high poly mesh like we had earlier with that construction light, maybe you want to change the percentage to a deviation, just like we did earlier as well. Maybe use a deviation of 0.01, 0.05, 0.25, 0.5, and so on. That is something you'll have to play around with, and it also depends on the input data you have. But in this case, using a percentage works like a charm because it is a clean input mesh that is not too dense. So, LOD 0 is the same original model, nothing to really look at here. Then again, on the top of the viewport, we've got these different tabs, so we can toggle through them. And even on LOD 3, with an almost 90% reduction, we've got an absolutely incredible looking result that you would typically never see from this distance, but if you wanted to, you could. So maybe you want to use LOD 3 as LOD 0 on the mobile application, right? And that would work without any issues. So if we just look at the wireframe, you can see the drastic change that has actually gone through here. And what is really worth pointing out here again is that we don't get any texture stretching. And again, all of that just works. All this works without having to worry about anything because of the clever algorithms that InstaLOD has. We don't just work on the mesh itself and arbitrarily remove edges somewhere. Because that is what a lot of other algorithms, other softwares do. InstaLOD looks at all of these different features and figures out, okay, can I remove, let's just zoom in here, can I remove this vertex over here, or will removing that vertex break the textures and create some incredible stretching of the textures on the model, right? So there's all these different things that InstaLOD looks at when optimizing. And that allows us to generate these incredibly high quality results. And again, it is worth mentioning the speed. This entire LOD generation was a matter of 5 seconds, which is incredible. So that sums up the generation of LODs. It doesn't really get much more complicated than that, to be completely honest. Very straightforward, very easy for the user to set up, and that's the whole point. So back to the presentation, and then we'll have a look at our final optimization, which is draw calls. So what I'm going to do is jump back to InstaLOD Studio XL. I am going to load my next and final scene, which is constructed of a bunch of different assets. So this is a city block, and I believe it's made up of 98 different objects, 40 different materials, a bunch of textures, and yeah, altogether ending up in 212 draw calls. And if we were to scale this across an entire level, the draw calls are going to scale as well. So you've got to be really careful with this. I'm going to go and create a new profile because we don't want to generate LODs here. We want to reduce the draw calls. So if we know that this is our final low poly mesh, let's just pretend that it is. We don't need to do any more optimizations. We now just need to reduce the draw calls. So let's just say maybe some of these objects have already been remeshed, other ones have already been optimized, we've got LODs for them and so on. Now we just need to reduce the amount of materials. So if we look at the materials here, we can see there's quite a big list of them. And if we look at the UVs, and if I just select this building over there and zoom out in the UV viewer, you can see here we have tiling UVs, and we've also got a bunch of textures on this single building, all right? Multiple 2K textures. Then we've got loads of other stuff flying around in the scene. We've got walls, we've got a bench, fridges, broken down vehicles, rubbish. There we go. Yeah, furniture and so on. And everything has its own UVs and textures. So there is a lot of stuff going on here. So what we're going to do is we are going to go to the material merge feature, and I'm going to start off by increasing the gutter size in pixels. And the reason I want to do this is because if we look at this model from a distance, potentially for an HLOD, I want to make sure that I don't get MIP map bleeding. So that's why we're going to space the shells with at least 15 pixels between them. Then we're going to allow the UV shells to be locked by 90-degree rotations. And the reason I'm doing this is pretty use case specific. And in my case, it's because of this brick texture. And I want to make sure that the pixel grid lines up with this grid of the bricks. So if I were to rotate this texture by some arbitrary number, I could end up with pixel stepping, and that wouldn't look fantastic. So with that said, we're now going to take the entire scene and bake it down into a single texture atlas. Now to do that, we would theoretically need to go pretty big on the output texture, because remember, a single building block has multiple 2K textures. So yeah, we would have to therefore increase this to maybe a 4K, 8K texture and so on. But what we're going to do is actually keep it on a 2K map. And the reason this works is because InstaLOD has a setting here called stack duplicate shells. Let me just click start. So what this stack duplicate shells does is it recognizes if we have duplicates in the scene. And with duplicates, I really mean duplicates, not instances. These are separate meshes that have been moved, rotated, scaled around the scene. But the UVs, the materials, the textures, they are all the same. So that allows InstaLOD to figure out where we have these duplicates and then stack those UV shells on top of one another to make the most of the output texture. And that is how, with a single 2K map, we can end up with a visually pleasing result, which is incredible. So if we just zoom in here, we can still see every single brick in the wall. Now, of course, we could bake this onto a 4K texture and end up with an almost identical pixel density to the input mesh. But the fact that we can do this on a 2K map without looking like garbage is incredible. This looks fantastic for what we have. You can see from 212 draw calls, we have reduced this to just 98. We're going to push this a bit further in just a minute. But for now, if we select the building again, you can see here we have those UV shells. If we select the next building and the next one and the next one, you can see all those shells are stacked. The same with the ground. The same with the walls. Those shells are stacked up here. So a fantastic optimization of the texture in regards to UV space usage. Now, to take the draw calls a step further, what we can do is take the entire scene, and we're just going to select all. Then we can go to Mesh, Combine, and there we go. We have one single mesh node utilizing a single material, which has a single color texture and a single norm map, and all of that is ending up in a single draw call. So if we select this now single mesh, we can see here those are all of the UVs that are stacked. We have one color and one norm map. Now, in a scenario like this, you might actually want to do 2 separate material merges, because you can see that 90% of this texture of the norm map texture is not used. It looks like we've only got 5 or 6 objects that actually use a norm map. So in this scenario, you might want to select those 5 or 6 objects and then do a separate material merge onto a 512 texture, and then select everything else and do a 2K bake from there, just to optimize the scene even further in regards to the texture pool. You would end up with 2 draw calls, but that's a good trade-off in my opinion. So that brings us back to our presentation. So again, with draw call, with the draw call optimization, we were able to first of all reduce the amount of textures by creating texture atlases. We drastically reduced the amount of materials by merging them, hence the name material merge, and ultimately reduced the draw call count from 212 to a single one. So if you, first of all, let's go back all the way to the beginning. If you apply these different steps to your scenes, right? Start off with optimizing, maybe generating your LOD zeros with the first optimization, then baking your textures, either remeshing them, or if you've got 16K textures as an input, you can bake those together down onto a 4K map, and so on, right? Generating your LOD zero with textures, generating LODs, and then finally you can finish things off with once you've maybe kit bashed your scenes or done your set dressing, you can then finish off your entire scenes with draw call reductions by using the entire InstaLOD toolkit. For example, you could use the Polygon optimizer for the initial optimization. You could use remeshing to include the second step of texture baking. You could then generate LODs with the optimizer, maybe do some more optimizations of foliage by using InstaLOD's imposter features. You could then do the final step of draw call reduction with the material merge feature, and there you go. So an incredible toolkit that we have at our disposal as artists when working with InstaLOD. So I hope that this was able to open your eyes and show you how accessible and easy the entire optimization of scenes, not just single assets, but entire scenes, can be. We don't have to waste time on technical aspects that much anymore. We can just let software take over and allow the clever algorithms to do all of the heavy lifting. If you enjoyed this video, drop us a comment below and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all of the links in the video description below. Thanks for tuning in, and I'll see you in the next one.